So this is where we left off, and it said solve each equation. So we're in the 5-3 section, okay? First of all, we're going to pay really close attention to these instructions, right? What does the instruction tell you or not tell you because it's missing? There's no interval. So if the interval is not given, then what? You have to add 2n pi or n pi. So for the one on the left, because it's sine cosine, we're going to add the 2n pi. And the one on the right, because it's tangent, we're going to add n pi. And we're only going to use from 0 to pi on that one. We're going to use 0 to 2 pi on this one. So again, you have to read those instructions. Like, it would stink to get points off because you did it correctly, but you answered it the wrong way. Like, you want to make sure you pay attention. And they are going to change. You're just going to get some with the interval and some without the interval. So you want to make sure you check each one. Yeah. There's 12. Yeah. Okay. There's no calculator on this one. Yep. Nope. It would kill you if you did multiple choice and you got one. If you got like the sign wrong, you're done for. Yeah. 12 questions. That would be brutal. All right. So for the left, 2 sine squared plus cosine of x minus 1 equals 0. I know I can't solve this as is. I need to get them to be the same trig function. I cannot replace cosine to the first. That is not in your Pythagorean identities. So sine squared is what you're going to replace. And since sine squared plus cosine squared equals 1, I would replace sine squared with 1 minus cosine squared. So I get 2 times 1 minus cosine squared x plus cosine of x minus 1 equals 0. And then I'm going to distribute here. So 2 minus 2 cosine squared x plus cosine of x minus 1 equals 0. Combine your like terms. So negative 2 cosine squared x plus cosine x plus 1 equals 0. And as soon as you see that cosine squared and the cosine, you know you're going to have to factor. Like, personally, I hate a negative on the front, so I would have changed this. I would have multiplied everything by -1, or I would have moved everything to the other side. You don't have to do this, but I would make that 2 cosine squared x minus cosine x minus 1 equals 0. And then you can either do trial and error or first times last. I feel like most of you picked first times last. We're going to do that. 2 times -1 is -2. Factors of -2 that sum to -1 would be -2 and +1. You can make those a's, like I could say a equals cosine x if it's easier. So it'd be 2a squared minus a minus 1. Or you could keep them as cosines. It's up to you. So I'd get 2a squared minus 2a plus a minus 1 equals 0. And then I'm going to factor by grouping. Take out a 2a. There's already a matching binomial, so there's a 1 on the front. And then I'm going to either solve, then plug the cosine in, or cosine and then solve. It doesn't matter. But if I split and solve here, I'd get a equals 1, 2a equals -1, and a equals -1/2. So I'm looking for where the cosine of x equals 1 and where the cosine of x equals -1/2. And then today you're going to fill out your unit circle. So you would be given this back. You would, in my opinion today, I would take obviously all the things that are there. I would add on the tangents for the next question. We'll go back to that. I would mark it for cosine and sine. You could literally say sine, cosine plus 2n pi. And you can say tangent plus n pi. Like, you can add that. You can add your all students take calculus. And you can add the tangents on. Just having that's going to help you out. So already I'm going to go back to my question. It says cosine of x equals 1. So I'm going to look for where my x, because that's what cosine, is 1. And it happens at 0. And I would do 0 plus 2n pi, because it happens there and every coterminal after it or before it. And then I'm going to go cosine 1/2. So I'm looking for where all my x values are -1/2, which is at 2 pi over 3, 4 pi over 3. And that is how I would leave my answer.
Can you just write 2n pi for the first?
Yes, you can put 0 plus 2n pi, or you can put 2n pi if it's 0. I'll take either one. Questions on that one? All right, then for the second one up there, it's going to be tangents. So I'm going to go ahead and add on my tangents right now. So this is, again, what I would do today when you get your unit circle. I would add on the tangent. So the tangent is 0 on the left and the right. It's undefined at the top and the bottom. And then every over 6, it's root 3 over 3. Every over 4, it's 1. Every over 3, it's root 3. If you want to do all 4 quadrants, go for it. Make sure you change the signs where they should be. If you want to, oh, that should be positive. If you want to just do the first quadrant and make yourself a note or something like that, that's fine too. This one's negative. So the more you can fill in today, the better off you will be tomorrow. Okay, so now this question says 3 tan of x plus 2 equals tan of x. So there's 2 tans, but they're both to the first power. I'm just going to combine them like they're like terms. So I could subtract 3 tan of x. And I get 2 equals negative 2 tan of x. Divide both sides by negative 2. And tan equals negative 1. And then there was no interval given, so I go to the top of my unit circle, and I want to find where tangent is negative 1, and that happens at 3 pi over 4. So it's 3 pi over 4 plus n pi. Yep.
So if there was an interval, you would use all the...
So if the question said from 0 to 2 pi at the top, that answer is going to be 3 pi over 4 and 7 pi over 4, because you would use the full circle. Yep.
For the tangent, you're trying to get tan x like by itself on one side?
Yep.
Okay.
For all of them, it's like that.
Maybe it says 0 to 2 pi for tan, you use everything?
Yep. If it says 0 to 2 pi, you use 0 to 2 pi.
Okay, it says solve just the first.
You have just the top and then add it. Yep.
For the cosine, for cosine where it equals, oh, it's one, never mind.
Good? Okay. So, and I like to go back to your question, Lauren, that's kind of the reason we're doing open-ended on this stuff. So let's say you accidentally use the full circle for tan, and you do 3 pi over 4 plus n pi, and you do 7 pi over 4 plus n pi. You're not wrong. You're just duplicating an answer. So it's not right. If it was multiple choice, you wouldn't see it. But I'm not going to take points because it's not wrong. Does that make sense? It's just a duplicate answer. All right, then came the sum and difference stuff. So we did these on the, So we did these like on the warm-up on Friday, but these are your sum and difference formulas. Remember, the pattern for sine is sine, cosine, cosine, sine. You keep the sine. Cosine is cosine, cosine, sine, sine. You change the sign. Tan is the sum in the top, 1 minus the product in the bottom, and the sign matches the top. So it's tan plus tan over 1 minus tan times tan. And if it's a minus, it's tan minus tan over 1 plus tan times tan. So if I got sine of 105, I'm looking for 2 angles that would add up to 105, or 2 angles that their difference would be 105. Can you give me one?
60 plus 45.
60 plus 45 works. So I would do sine of 60 cosine of 45 plus cosine of 60 sine of 45. I would have gone back to the unit circle. I would have found 60 degrees. The coordinate point there is 1/2 root 3 over 2. And then I would have gone to 45, and the coordinate point there is root 2 over 2 and root 2 over 2. So sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. Cosine at 60 is 1/2. Sine at 45 is root 2 over 2. and I get root 6 over 4 plus root 2 over 4, or root 6 plus root 2 over 4.
If the second number had like a different denominator, would you have to change
It can't.
You can't change it?
It won't. Like, think about all the denominators in your whole circle. They're all 2s. So it's either going to be a whole number, like 1s and 2, like that, like
Or-
0 or 1, because of the top and the bottom, right, left, maybe.
Yeah.
Or it's a fraction, and the fractions are all over 2s.
Okay.
If it was the tangent one, right, tangent's the one that sometimes they're over 3, sometimes they're not, you'd find like the least common denominator. Yep. All right, then you had the reverse of these, write the expression as the sine, cosine, or tangent of the angle, then find the exact value. So if my pattern is cosine, cosine, sine, sine, which trig function? Cosine, keep or flip the sign. Flip it. So it's cosine of 70, and this plus becomes a minus, so minus 10. Cosine of 60, and we just looked this up because it's up here. The cosine of 60 is 1/2. So like if you go to do that question, let's say, and you accidentally add it, and you get cosine of 80, and it says find the exact value, hopefully that's a good, like, something's wrong, because 80 is not on our unit circle. If it just said to get it into one trig function, then it can be any angle. But if it actually says then find the exact value, you would have to be able to find it using your unit circle. All right, then came the triangle ones. So on the right here are your Pythagorean triples you want to make sure you know. 3, 4, 5, 5, 12, 13, 6, 8, 10, 7, 24, 25, and 8, 15, 17. Those are going to certainly save you time. And then read your instructions. Find the exact value of the following under the given conditions. The sine of alpha is 7 over 25, where alpha is in quadrant 2. The sine of theta is 3 over 5, where theta is in quadrant 1. So when I draw these out, I want to put them in their quadrant so the signs make sense. Quadrant 2 means I'm going left and up. And I would put alpha in that corner. Sine is opposite over hypotenuse, so opposite is 7, hypotenuse is 25. My adjacent side would be what? 24, but also negative 24. So be really careful. Then theta is in quadrant 1, so I'm going to go right and up. This is opposite is 3. Hypotenuse is 5. Missing side is 4. Positive because we're in the first quadrant. Now it could say any of the 3 trig functions. This time it says cosine. So pattern is cosine, cosine, change your sign, sine, sine. Cosine of alpha is 7 over 25. Cosine of theta is 4 over 5. Nope, sorry, cosine is not 7. Cosine is negative 24 over 25. And then cosine of theta is 4 over 5 minus sine of alpha is 7 over 25. And sine of theta is 3 over 5. If you do this correctly, there should be a like denominator. So 24 times 4 is 96, negative 96 over 5 times 25 is 125, minus 21 over 125. They're both negative, so I add them together and I get 117 over 125, and it's negative. Questions on that one? So when you open the review, if you look at numbers 55 and 56, okay, pay attention to the instructions there, because remember these multiple angle ones are weird when it gives you the interval. So in the original question, it did give you the interval, sorry. If it gives you the interval, then your answer looks like this. You have to include all those angles that would fall in it. If it doesn't give you the interval, then it looks like this. So I put both styles of answers because you can get both sets of instructions, okay? If it didn't give you the interval, then you would just find your angle, add the 2n pi or the n pi, and then divide it by the number next to x, or multiply it times the number under x if it was a division thing, okay? But if it does give you the interval, remember you have to do what we just did, but then you actually have to find the angles that fall between 0 and 2 pi. So I'd take that n, make it 1, and I would keep adding pi over 3. On the left, I did the same thing. So 55, this first one would be if there is no interval given. And the bottom is if there is an interval given in the instructions. So make sure that you would know how to do it both ways. The PDF review. I don't know if that's a good sign or a bad sign, people. It's either you're so prepared you're not confused at all, or you haven't done it yet. Okay, so normally if there's a sum and a product, I'm going to do the sum, or the difference in this case on the left. But I know I kind of want to keep them in the same term. So like one of the things I might have done is with cosine, I can make it like 1 minus sine squared, something like that if there was a sign on the right. But as it is, I want to just see if I can combine these into one fraction, into one term, because that's how it is on the right. So cotangent would be the same thing as cosine squared over sine squared minus cosine squared. And then if I wanted to make that a like denominator, I'd have to give this sign. So I'd multiply by sine squared and sine squared in the top and the bottom. So cosine squared x minus cosine squared x times sine squared x would all go over sine squared x. And then I can actually take the cosines out, cosine squared x, and make it 1 minus sine squared x. Oh, so it would have been the same thing if I had done that from the beginning. And 1 minus sine squared x is what? Cosine squared x. And now I've got it down to like one fraction. Keep checking over here. There's a cosine squared. If I just break this apart, so if it's a product, both don't get the denominator, only one does, then I can take that cosine squared over sine squared and I can make it cotangent squared times cosine squared. Yeah. So if I had done, and so I could have made this 1 minus sine squared from the beginning too. I don't know if that would have made much of a difference, but because I would have still had to give it a like denominator, but it could have happened there. So when you open the review, this is, all right, so 75 is kind of like the one we just did, except that it's sine. So it'd be sine u cosine. Okay, so plus cosine u sine v. Okay, so you can just draw them separate if you want. Like they don't have to be on the same. Yeah. So they're both in quadrant 2, right? Okay, so left and up, u, and then I can draw another one. Left and up, v. So u sine is 4 over 5. That means the missing side is negative 3 because it's in the second quadrant. And then v cosine is negative 7 over 25, and the negative goes on the 7 because it's x, and we're moving left, and also because the hypotenuse can't be negative. And then the missing side there would be 24. So then the pattern for sine, sine, cosine, cosine, sine, keep the sign. So sine of u would be 4/5. Cosine of v would be negative 7 over 25, plus cosine of u, negative 3/5, sine of v, 24 over 25. So I get negative 28 over 125 minus 72, or plus a negative, which is the same thing as minus 72 over 125. They both have negative, so we add them. 100 over 125, and then that can get reduced 4/5. You're welcome. Other questions? So like the 5-1 stuff, 5-1 and 5-2, there's actually only one that's like full on verifying, because you're gonna see it come back again later in something like these. So like 81 and 82, you're verifying, but you're using sum and difference. So those kinds of things. And anytime it says to verify, you have to show all your steps. Do not skip steps. Like it would stink to get points taken off just because you skipped your steps. Anytime it says verify, you gotta make sure you show every single step. So if you're using like the trick and you're moving from bottom to top, you have to give me an arrow. Draw it from bottom to top. That's how I know you did that step, that kind of thing. If it said sine squared plus cosine squared, and then you go to, like, you skip that equals 1 step, you have to make sure you show that step.